Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about integration of the power rule. We're going to evaluate each indefinite interval. So, if I was given this interval, the integral of negative 24 x to the fifth dx. Okay? Well, if I want to evaluate this, right, take the integral, right, I'm going to reverse kind of like the power rule, right? I think about power rule derivatives, we're reversing that. So I have, well, x, instead of subtracting 1 from x, but I'm going to add 1. So I'm going to add 6th power. I'm going to leave the constant out front, negative 24, but I'm going to divide by that 6th power. Now I can't forget, there's nothing else there, so I have my plus my constant. So now I have negative 24x to the 6th power divided by 6. Okay? Well, I can simplify this. 6 goes into 24 4 times. And so we have a negative 4x to the 6th power plus c. Oops. Plus c, not 6. We've got 6's on the line right here. Plus c. And there we have it. Our final answer, our integral, right? We found the indefinite integral right here. So negative 4x to the 6th power plus c. Integral of negative 3 dx. So what I like to imagine is that the negative 3 has x to the 0 power right next to it, right? So if we add that exponent, right, add it by 1, so we have negative 3 the constant, x to the first power divided by that exponent 1 plus c, right? There's nothing else that we can add there, so we always have that constant. Now, 1 divided by negative 3, we don't really need that 1 or this one, and so the way it's simply negative 3x plus c. Whenever we have a constant, this is going to happen. Whenever you just have a constant, and we need to integrate just the constant part, we can just add the x next to it. Again, don't forget plus c, but either way, our final answer is negative 3x plus c. The integral of negative 6x dx. Right. So, if I take the integral of negative 6x dx, right, I see that this exponent, or x, has the first power. So, I have to add that power by 1. So, we have negative 6x here, keep that negative 6 out front. But the x, instead of having 1, we add 1 to it, so 2. We also divide by that exponent as well, 2. And then don't forget our plus c. So now we've taken the integral, right? But now we can simplify. So negative 6 and 2, simplified to be negative 3, so negative 3x squared plus c. And that's it. Our final answer right here is pretty easy and quick here. Our integral is negative 3x squared plus c. Integral of 12x squared dx. Okay? So the integral of 12x squared dx, well, power rule states, right, I have to add that exponent by 1. So leave the constant up front, take the exponent, I add it by 1, so 2 plus 1 is 3. And then I divide by this new exponent, 3. Now I can't forget my plus c. So from here, I've taken the indefinite integral, I just need to simplify. 12 divided by 3 is pretty easy, that's a 4. So we have 4x to the third plus c, and that's it. That's our final answer. That's our indefinite integral of negative 24x to the 5th power minus 10x dx. Okay. Now, what we can do is take the integral of both parts, right? Both parts individually here. So we do the power rule on each one here individually. So with that, we look at the negative 24x to the 5th. Well, I'm going to keep the constant, negative 24, and then the x. But I'm going to raise that exponent by 1. 5 plus 1 is 6. I then have to divide this part by 6 as well. So we have subtraction out here, so minus. We have the 10x, right? But then I have to raise that exponent by 1. Well, it's the first power, so raising 1 is the second power. And then I divide this second part here by 2. And I can't forget my plus c. So now I've taken the integral, I just need to simplify that. So negative 24 divided by 6 is a negative 4, so we have a negative 4x to the 6th power minus, well, 10 divided by 2 is 5, so minus 5x squared plus c. And we have our final answer. And I go here of a negative 9x squared plus 10x dx. Okay? Well, I'm going to take the power rule, really, the integration power rule, of each part individually. We can take the integral of each part here. So let's do the first part. I'm going to keep the negative 9 out front, and the x, but I raise that exponent by 1. 2 plus 1 is 3. So that third power, I also divide this whole thing by 3 as well. Now let's do the same thing with the 10x. We have 10x here. Raise the exponent by 1. X to the first power plus 1 is x to the second power, right? Or the exponent by plus 1. And then divided by 2 right there. And then don't forget our plus c. So we have the 2, with the 2 down here, and we have to add the c. So now we've taken the integral, we just need to simplify. 9, or negative 9 divided by 3 is a negative 3. X to the third power, plus, well, 10 divided by 2 is 5. X squared plus c. And there we have it, final answer. Negative 3x to the third plus 5x squared plus c. So the integral of 4x to the negative fifth power dx. Okay. Well, by using the power rule, right, all I'm going to do is still add the exponent by 1. So we have the 4 comes down the constant x here, and now we have negative 5 plus 1. Well, negative 5 plus 1 is a negative 4. And we need to divide by that same exponent. So divide by negative 4 as well, and plus c. So now we've taken the integral, but we can simplify this a bit here, right? 4 divided by negative 4 is a negative, right? Negative 1. So we have a negative out front here, okay? And we see that x to the negative fourth power, I can rewrite that to be x to the positive fourth power in the denominator, okay? So I have 1 over x to the fourth power, the negative out front, and then I have my plus c, and there we have it, our final answer. Negative 1 over x to the fourth power plus c. Integral of negative 2x to the negative third power dx. Okay. Well, to evaluate this using the power rule, I'm going to keep my constant out front, right, the x, but I'm going to raise this exponent by, well, 1. So negative 3 plus 1 is a negative 2. We need to divide by that exponent again. So negative 2 up here, negative 2 down here, and don't forget the plus c. Okay. So now we've taken the integral, we just need to simplify. Negative 2 divided by a negative 2 is a positive 1. Now I'm not going to write 1 just yet, right? So there's a 1 out there multiplying, okay? Now x to the negative 2 power, we can write that in our denominator, right? So we have x to the positive 2 power. So here's the 1 up front, right? 1 divided by, well, x to the positive 2 power, the second power, but in the denominator. We have a plus c here, and that's it. Here's our final answer. 1 over x squared plus c. Integral of a negative 2x to the negative third power plus 20x to the negative fifth power dx. Okay. So what I need to do is treat each part individually. So I think about the power rule of this first part. Well, the negative 2 is a constant, I'll leave it out front. X, now we raise the exponent by positive 1. So negative 3 plus a positive 1 is negative 2. We divide that by that exponent, a negative 2 right here. Then we've done basically everything we need to do with this first part. Let's give the second. 20x, right? Keep the constant out there, x. Now we raise the exponent by 1, positive 1, so negative 5 plus 1 is a negative 4. And we divide it by that exponent of negative 4. Don't forget my plus c right there. Okay. So now, let's see what we can do to simplify. Negative 2 divided by negative 2 is a positive 1. Great. And then we have the x to the negative 2 power. I put that in the denominator. That's x to the positive 2 power. Right? So I have 1 over positive 1. Right? Negative 2 divided by negative 2, positive 1. X squared. Plus here, same thing. Well, 20 divided by negative 4 is a negative 5. So with this plus sign, I can really make it a minus by 1 here. Minus, I have 5. Now, x to the negative fourth power, I can make that to a positive fourth power, the denominator, divided by x to the positive fourth power. Okay? And then don't forget our plus c. And so there we have our final answer. It is 1 over x squared minus 5 over x to the 4th power plus c. The integral of the negative 4 x to the negative 3rd power minus 20 x to the negative 5th power dx. Okay. Well, what I want to do here, and look at my power rule, right? Negative 4x to the negative 3rd. Well, I deal with that first part. Negative 4 constant stays up front. We have the x. But we add the exponent by 1. Negative 3 plus 1 is a negative 2. I then divide that by a negative 2. Bring that same exponent down here. Minus, well, let's keep that 20. Constant x. Now let's raise this exponent by 1. Negative 5 plus 1, positive 1 is a negative 4. And I divide this by that negative 4 as well. Now we don't forget our plus c. So now we just need to simplify. With negative 4 divided by negative 2 is a positive 2. And x to the negative 2nd power, we put in the denominator to be x to the positive 2 power, right? It's in the denominator. Now, 20 divided by negative 4 is a negative 5, but negative is a positive, so we have positive 5. Okay? And then x to the negative 4th power, we can put that in the denominator to be positive 4th power. So x to the positive 4th power down here. And don't forget our plus c. And then we have our final answer. 2 divided by x squared plus 5 divided by x to the 4th plus c. And the integral of negative 4 over x to the 3rd minus 8 over x to the 5th dx. Now, one thing I like to do when I have a fraction with the variable in the denominator with the integration, I like to rewrite this to have, well, the exponent in the numerator. So this negative 4 would be x now to the negative 3rd power, right, minus 8x to the negative 5th power dx. And I find that's a little easier to deal with, especially when you're doing the power rule here, okay? That's my preference. So at this point here, I'm now going to take the integral. I keep that constant, negative 4 out front, but now I have to add the exponent by 1. Negative 3 plus 1 is a negative 2, right? So we have x to the negative 2 power, but I divide that by negative 2 as well. All right, we have minus the 8 here, but then we have x to the negative 5th power. We add the exponent by 1, so we have a negative 4th power over, right, divided by that same exponent, negative 4. And don't forget our plus c. So now from there, it's fairly simple. We just need to simplify this, right? Negative 4 divided by negative 2 is a positive 2, right? Positive 2. But x to the negative 2nd power goes back to the denominator, x to the positive 2 power, right? Now with 8 divided by 4, our negative 4 is a negative 2 as well, but there's a negative out front, right? So it's positive 2, so we have positive plus 2. And x to the negative 4th power is rewritten to be x to the positive 4th power in the denominator. And don't forget our plus c. And so there we have our final answer. 2 over x squared plus 2 over x to the 4th plus c. The integral of 15 over x to the 4th plus 8 over x to the 5th dx. Okay? Well, what I want to do is, well, what I like to do personally, okay, I like to rewrite this, okay, and I'll do it right here, so it's kind of on the side, but it's okay. Rewrite this, okay, to have our exponents be, well, in the numerator, but they're going to be negative. So we have 15, I don't think the integral, I don't forget that one. Erase this here, so the integral of 15 x to the negative 4th power plus 8 x to the negative 5th power, right? Bring that back up there, then dx. Okay? And I like that easier when I'm dealing with power rule. Makes it a little easier to solve. Okay? So, now let's take that integral. So here we're going to take the integral. Well, keep the constant up front, 15. And now we take the exponent and we add 1 to it. So negative 4 plus 1 is a negative 3, and we divide by that exponent, negative 3 right there. Plus here, well, 8x, add the exponent by 1, so we have a negative 4 now, right? And divide by that negative 4 as well, and plus c. So now from there, we need to simplify. 15 divided by negative 3 is a negative 5, so we have a negative 5 out here. And then we bring the exponent back to the denominator, x to the positive third power. Same thing here with the 8. 8 divided by negative 4 is a negative 2, so we have minus 2 here, right? Minus 2. But then, that exponent we put back in the denominator, x to the positive fourth power, and then we have a plus c. So again, our final answer here is just negative 5x to the, over x to the third power, minus 2 over x to the fourth power, plus c. Integral of negative 14 x to the 5 half power over 2 dx. Now, you're going to have to be pretty good with your fractions here, okay? So the same rules still apply. Keep my constant up front, negative 14. X, now we add the exponent by 1. 5 halves plus 1, well, is 5 halves plus 2 over 2, which is 7 halves. So 7 halves right here, right? And divided by, well, 2's out front, we bring a 7 halves to the denominator. 7 halves, okay? And don't forget our plus c. So this is actually pretty quick to simplify, okay? 2 and 2 cancel out, right? 2 divided by 2 is 1. And then 7 and the negative 14 is a negative 2. So we have a negative 2 x to the 7 halves power plus c. That's it. That is our final answer. Integral of negative 35 x to the 2/5 power divided by 5 dx. Okay. Now, you always, of course, could simplify right from the beginning, right? It's up to you. I'm not here. And actually, I think it's easier not to. Kind of knowing ahead, but up to you. So, power rule, we keep the constants out front. So, negative 35, right? Negative is still there. And then x, we raise the exponent by 1. Okay. Well, 2/5 plus 1 is 2/5 plus 5/5. So, we have a 7/5. Hopefully, you're good with your fractions. 5 stays down here, and then we're divided by that 7/5 power, okay? And this is why here, well, sorry, plus c. Don't forget, I almost did. And this is why I kept the 5 in the denominator. 5's will cancel right here, eliminate, and then negative 35 divided by 7 is a negative 5. So we have a negative 5 x to the positive 7/5 power plus c. And there we have our final answer. I have the integral of a negative 5 third root of x squared over 3 dx. Well, the first thing I like to do here is I don't like roots when I'm taking integral. I like to make everything into a fractional exponent. I find it easier, so I'm going to do that right here. So we still have the integral. We have a negative 5, that doesn't change. But instead of x to the third root of x squared, I'm just putting x to the, well, 2/3 power over 3 dx. And that's going to help me. All right, so definitely I recommend that. Put it to a fractional exponent. That's how we use the power rule. Okay? So now we take the integral. We have the negative 5 staying up front here. We add the exponent by 1. Okay, so 2/3 plus 1 is the same thing as 2/3 plus 3/3. So 2/3 plus 3/3 is 5/3. So we have x to the 5/3 power here. We have 3 down here, but we have to divide by that exponent by 5/3, and don't forget our plus c. Okay? Well, luckily for us, the 3's cancel right here. We can cancel that out. And the 5 and negative 5 divided by 5, what's left there is a negative 1. So our final answer is a negative, just x to the 5/3 power plus c. Integral here of a negative 5 4th root of x over 2 dx. Well, the first thing I like to do is to rewrite this without a root, but with a fraction exponent. So, I have the integral here of a negative 5 with x to the, well, fourth root is the 1/4 power over 2 dx. Okay? Now from here, what I want to do is, well, take the integral, but we use the power rule, so the negative 5, okay? X to the 1/4, we add exponent by 1, so 1/4 plus 1 is 1/4 plus 4/4, which is 5/4. Okay, 5/4. And we divide that by, well, 2, and we multiply that by 5/4. So I'm going to break up 5/4 actually like this, 5 over 1 and 1 over 4. Same thing, see 5/4, but it kind of separate out. It's going to make it a little easier for me to see the next thing that I'm going to do. And then don't forget our plus c. Okay, so what I'm going to do here now, okay, let's go simplify some of this. 2 and the 4, here is just a 2. Okay, so we have a 1/2 right here now. And the 5 and negative 5 right there cancel out. We just have a negative 1. Okay, so now we have, if we're dividing by a 1/2, right? Divided by a fraction 1/2, the same thing as multiplying by 2. So negative, or 2 times a negative 1, we have a negative 2 out front, x to the 5/4 power, plus c, and there we have our final answer.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.